Improper integrals. So in this section, we extend the concept of a definite integral to the case where the interval is infinite. So what do I mean by that? Well, I mean, in this case, if you look at the picture, we're asking what's the area under the curve from 1 to infinity. We've never seen that before. It's always 1 to 7 or 1 to 6, some sort of finite number. And we're talking about the function 1 over x squared. And we're saying to ourselves, does this actually equal a number? It's a crazy thing to think about because you're saying there's no way it can because it goes on forever. But crazy enough, we sometimes get an answer for these problems. So I want you to consider the infinite region S that lies under this curve, 1 over x squared. Have it be above the x-axis and to the right of 1. Now you might think that S is infinite because it goes on forever, but actually that's not necessarily the case. You're starting to say, are you sure? This seems a little crazy. So again, I'm going to pose this question. Here we have the area is 1/2 because it's that finite area. Here we have the area is 2/3. Here we have the area is 4/5. Here, this goes on forever. We're going to let x go off to infinity. So is there an actual number answer to this problem? Well, I don't know. Is there? Actually, I do know. Before we answer that question, though, I need you to know this vocabulary. I'm going to start using it, for forever and ever, for the rest of your life. So convergence versus divergence. To converge means that the area under the curve is equal to a finite number. So it's almost saying like the area under the curve here is 1 or 2 or 2/3. Versus it diverges if the area under the curve is equal to infinity, meaning it never gets to one number. And so you can see how this would keep going on forever. We'd never get a particular value. So that's called diverges. So convergence is when you have a finite area. It actually gives you a number. Divergence is when the area under the curve goes off to infinity. So here's a really cool rule here. You can see I already started this video and redid it. The thing is, if we have an integral from 1 to infinity where we've got a p, x to the p, and that p is greater than 1, it does converge. It's kind of like a rule. It's a formula. And it converges to 1 over p minus 1. So for example, if we go back here we have 1 over x to the p. So obviously our p is equal to 2, and that p is greater than 1. So in this case, we look at our rule, and because p is greater than 1, it converges. So I would say that this converges. And specifically, it converges to 1 over p minus 1. Which in this case, since my p is 2, would be 1 over 2 minus 1, which would be 1 over 1, which is 1. So remember how I said it's equal to a finite number? Well, in this case, the integral from 1 to infinity of 1 over x squared actually is equal to just the number 1. And the reason that is true is because my p is greater than 1. Here, you can see my p is actually equal to 1, so my p is not greater than 1, so this one actually diverges. You have to be bigger than 1 in order to converge. So certainly you could memorize this, but it's not my favorite way to do these problems. I'll show you in another slide or two how to do it my favorite way. So if I asked you from A, B, C, and D, do these converge or diverge? Here the p is 4, so we would say that it converges. Because the p is 4, it's going to converge to 1 over 4 minus 1, which is 1/3. So not only does it converge, it converges to an area of 1/3, and you just found the area. Here I can rewrite this as the integral from 1 to infinity of 1 over x to the 3/4. And 3/4 is not greater than 1, so this one diverges. Okay, this one here is going to be the integral from 1 to infinity of 1 over x to the 5/4. And because 5/4 is greater than 1, this one does in fact converge. And it converges to 1 over 5/4 minus 1. You can write that as 1 over 5/4 minus 4/4, which is 1 over 1/4, which is actually 4. So not only does this converge, it converges to 4. All right, this next one here, we have 1 over x to the negative 1/4, and clearly negative 1/4 is not greater than 1, so this one diverges. And so, like I said, this is one way to do this problem where you kind of rewrite it as 1 over x to the something. You look at what that p-value is, and if it's greater than 1, you can find what it converges to by using that formula. If p is not greater than 1, like in this case and in this case, we say it diverges. So there's an alternate way to do this, and it's actually my preferred way. It says actually calculate the integral. Now I'm going to use this notation right here. Technically, every time we use that, we should have used the notation the limit as t approaches infinity from a to t, where I'm letting t go off to infinity. I think it's kind of unnecessary, even though this is a little bit higher mathematics and more technically correct. For the sake of getting our correct answers, I'm going to be okay with using this notation. So let's get her done. I'm actually going to integrate this and solve. So I'm going to rewrite this as the integral from 1 to infinity of x to the negative 4 dx. And literally just solve this. So this is going to be x to the, add 1 to this, right? That'd be a negative 3 over negative 3 from 1 to infinity. Okay, so now I'm going to rewrite that as negative 1/3 x cubed in the denominator here. And we're still from 1 to infinity. So this here is going to be now plugging in my top value. So I'm going to have minus 1 over 3 to the infinity cubed minus a negative 1 over 3 to the 1 cubed. All I was doing was plugging in this first to get here, put down my minus symbol, and then I put the 1 in right here to get this. So let's go ahead and simplify this. This is obviously going to be a minus. Minus becomes a plus. So I can erase that. And we should think about this as negative 1 over a huge number, right? Infinity cubed is huge. So big we can't even think about it. So this becomes 0. And then this becomes plus 1 over 3. So our answer is 1/3. Now we know that that's true because our p-value is 4, and we know that this is 1 over p minus 1. 1 over 4 minus 1 is 1/3. So I just kind of checked that my answer was correct. All right, this next one here, let's do this the long way because I know we want practice with it. This is actually b. So I'm going to rewrite this as 1. I know I don't need to rewrite that. Let's just add 4 over 4. So this is going to be x to the negative 1/4. Take the reciprocal of that. We'll have a negative 4 out in front. And that's going to be from 1 to infinity. Let's rewrite this as a negative 4 over x to the 1/4. Okay, and that's going to be from 1 to infinity. Okay, so here we're going to have a negative 4 over infinity to the 1/4 minus a 4 over 1 to the 1/4. Well, this whole thing right here gives me 0. This minus becomes a plus, and this becomes plus 4 over 1, which is 4. And I believe we've already done this problem, and we did find it to be 4. Yeah, it was this one right here. We've already done this problem. It was 4. So folks, you can see that there are two different ways to do this. The thing is, I like this method better because It doesn't necessarily have to be 1 to infinity. It could be anything, and you can use this method. However, if you're using this method, it does need to be, if you use this method right here, it does need to be from 1 to infinity. Of course, your one on your test is going to be from 1 to infinity, so you could use either method that you like. Thanks for watching. Have a beautiful day.